That's the number for that.
That 2 can have a point. That's one problem with number 4. What's another problem with number 4? Say it again. It's cubed. All the other ones we've been factoring them in squared. So do we know how to factor this? When do we use SOAP? You can have a point, only 5. When do we use SOAP? Why is this not a SOAP problem?
It's not so problem because it has 3.
It has 3 terms. That's one issue. Thank you. You can have your point. SOAP problem would be for perfect cubes, like 27x to the third minus 1. That would be a SOAP problem. We don't have perfect cubes. 1 is a perfect cube, but 3 definitely isn't. So what words are we going to put on number 4? Yes, 2 can have a point, not factorable. Okay, number 5. God bless you, and you can have a point. We're going to group, take out an x squared, 5x minus 7, take out a minus 3, 5x minus 7. I have x squared minus 3 times 5x minus 7. She did not waste any time on that. If this problem had been set equal to 0 and we were supposed to find the actual answers, the roots, what is this real root? 5 gets another point. This one would give us 2 real roots. What are those 2 real roots? And 5 gets another point. Why on the bottom have I circled 7 and 10 but not 6, 8, or 9? What's different about 7 and 10 compared to 6, 8, and 9? Yes, 5, you can have a point. They don't have the little number, the little index, the 3, or the 4. They don't have one listed, so what's their understood one then? No. What would you call this symbol? Nah, that is one way to word it, but there's another name for it too. Yeah, you say square root, which means it's an understood 2. They don't write it when it's an understood 2. We can if we want to, because clearly we've forgotten that. So sadly, what everyone else is dealing with tomorrow that you'll have to postpone until Monday is the fact that how to deal with the nth roots, to deal with a 3, a 4, or something besides a 2, which we've talked about in the past, but it's been a while. For instance, 6 divided by 3 is 2, so I know an x squared is going to come out. 16 divided by 4 is 4, so I know y to the 4th is going to come out. It's not that deep, but we haven't done it in a while, so it might be that deep. It feels that deep. Okay, I need 2 numbers that multiply to 32. One of them needs to be a perfect square. Say what now, Gilberto? 8 and 4 are great. There's a bigger one. And yes, every group of 3 have a point. 16 and 2. Okay, so I know the square root of 16 is 4. I know there's a 2 left under the house. So I've dealt with the 32. I've yet to deal with that negative part. What do I do about the negative? Yes, I bring on an I. Thank you, 5, get another point. So the negative goes with the I. Now to deal with the x to the 4th and the y to the 7th. Anyone but 5. X squared and what? And then the house has just a y. Perfect. So your answer should have a 4 and I, an x squared, a y to the 3rd all outside the house, and a 2 and a y under the house. Perfect. Okay, number 10, I need 2 things that multiply to 18. One of them needs to be a perfect square. What multiplies to 18? 9 and 2. 5 gets another point. 9 and 2. I know the square root of 9, it's 3. I don't know the square root of 2. So I brought down the 3x because it already happened. It was already outside. I just brought it down. I broke down the 18 into the 9 and the 2, which led me to the 3 coming out. Now to just deal with that x to the 8th, what should come out? X to the 4th. And so my final answer is for a point. Yes. Yes. 3 times 3 is 9. 4 plus 1 is 5. 9x to the 5th square root of 2. Paige gets a point. Again, you can't help the way things are timed out. I get that. Like, I can't help that yesterday was ACT. We can't help the things we cannot help. But the things we can control is that on Monday, we're going to have to work quickly. Because everyone else is going to spend 2 days on something you're only going to spend 1 day on. Because you need to test next Wednesday. When everyone else gets to try and start the test Tuesday, you need to test next Wednesday absolutely for sure. So I can grade it. Because we would like for me to grade your test. Okay, let's go to your new notes, which we just passed out. 2 points. What did we talk about 2 days ago? Say it again, ma'am. That's one of the words I'm looking for, so you can have 2 points. What's the other word I'm looking for? One gets 2 points. We were talking about inverses, which we like. And specifically, we were going to use Fogg and Goff to check to see whether or not two functions were inverses. They are inverses if Fogg and Goff match. Not only do Fogg and Goff match, but Fogg and Goff give us what value? We get out just an x. Yes, 5 get another point. We did Fogg, we get a Goff. If we get out x for both, that means they're inverses. If we don't get out x for both, they're not inverses. Now, again, we keep having sporadic days, and we're about to move, and I want you to remember all the things all at once. So, for the love, it would be smart of you, since you really haven't been assigned much homework, please, it would be smart of you to take the study guide and work through the problems you already know how to do, so Cooper doesn't forget, because by the time the test comes, maybe he's forgotten what Fogg and Goff mean. Okay, today we're going to graph square root functions. And it should be pretty easy, pretty nice day. Square root function, so I'm not going to read you the notes on the front. You can go through them if you want. A square root function looks like an arm. I call it an arm. The original parent starts at 0, 0. Why do you think the square root function is just this way? Why do you think it is not like a butterfly or something? Why does it not exist over here? Why is it only going on to the right in that first quadrant? Yeah, it has to be positive. It can't be negative. So 2 and 5, and then get a point. And then, but let's think about why. So over here, we're talking like square root of 4. Hey, I know the square root of 4. That's 2. That's fine. But we can't do a negative square root of 4. That's going to involve I. And do we see i's on the graph? No, the imaginary stuff we never actually see on the graph, like not near that axis or whatever, so it's not going to happen. So we're only going to be in the positive land, hence why we only have the one arm. It looks to me like a lazy arm for a high 5 for the most part, which is why when it's negative it looks like a low 5. But we'll come back to that. Okay, I am trying to rush you through, I know, I'm sorry. So we're only going to work 4 examples. So we're going to start on the second page on the bottom. I want to do a bit of a refresher for your graphing skills because you actually, even though you've not dealt with this arm before, you should already know what that minus 5 is going to do to the arm because you've graphed a lot of other things. For instance, you've graphed a lot of quadratic functions, a lot of parabolas. What did the minus 2 do to me? How does that minus 2 make me move? What is that plus 5 on the outside? How does that make me move? Paige gets a point. You see how Paige remembers how it's supposed to move? Literally because the 2's on the inside, it was left or right. And remember, it was the opposite of what we thought. The 5 on the outside is exactly what you think. Plus 5 means up 5. Not only did we do a lot of this with with quadratic functions, but we also did a lot of this with absolute value functions. So what if it was the problem? How does that 3 make me move? How does that, yes, it makes me move left 3. And then how does that negative 2 on the outside make me move? Okay, so again, if it's inside, it makes you move left, right. Depending on the sign, it's opposite of what you think. And the outside makes you move up, down. And that one's not the opposite of what you think. It's actually exactly what you would want it to be, where if it's plus, it moves up. If it's minus, it moves down. So keeping all that in mind, when I see number 1, I automatically know what that minus 5 is going to do. Because it's on the inside, how does that minus 5 make me move? We assume it's going to make us move right 5. So we assume, and I'm going to graph the original guy. So there's this original guy, and we'll come to him in just a second. We'll just put the 1 point for now. But we assume it takes this original guy, and it picks him up and moves him 1, 2, 3, 4, 5 to the right. Now, I wish I could spend days and days on this with you because you are very smart, and we could talk about how I graph this in my head. So I'm going to briefly describe that, and if you got it, great. And if not, you and I both know I'm going to show you how to do it in the calculator too. Okay, so the original guy involves all our square roots. So I know the square root of 1 is 1. What's the next perfect square number after 1? 4. Square root of 4 is what? 2. So I would go up 2. And then after 4, the next perfect square is 9, 6, 7, 8, 9. So I would go up 3. So genuinely, Miss Compton just knows that. It involves all my perfect squares. But sad day, this pink guy is not our problem. Our problem, because I just graphed, this is just, our problem is the green guy who's already off the grid, almost off the grid anyway. So we took the pink guy, we picked him up, and we moved him to the right 5. I'm still going to go over 1 up 1. If there was room, I would still go over 4 up 2. If there was even more room, I'd still go over 9 up 3. It ends up still being an arm that's slowly increasing. But I can pick on, Justice, can I pick on you today? Okay, Justice is so lazy, and he just can't. He just can't. He doesn't want to think about this. He doesn't want to consider what I just said. He just wants to graph it. So he's going to go on his calculator. He's going to press y equals. To get to the square root button, you press second. And then where the x squared is, there it is in blue. Square root x minus 5. Yep, I have it typed right. There's anyone having a button issue. I press graph. Here we go. It looks pretty good. How can I get this onto my paper? I could press, I heard, we're going to come back to you too, and you can have a point. We could press trace, and trace is great because it'll tell me like, is that really at 5? Oh yeah, it really is 0 at 5. Trace is great, except I don't know how to graph these decimals. So I'm with Angel, and that's why she got a point. If we go second table, well, no wonder there's an error. We can't do negative square roots, but it said we were supposed to graph 5, 0. We did. The next nice pretty number, it says to graph 6, 1. 6, 1 we did. The next nice pretty number it says to graph is 9, 2. And if we can pretend, this really does look like 9, 2. So I can use my table, find the pretty numbers, like 14, 3, and only graph those. And Miss Compton will never know that I don't know what she was talking about when she was just graphing in her head. Because I still have the correct graph using my table. Are there any questions about number 1? We're not done, and we'll have to come back to it. Why are we not done? What do the directions say that I'm skipping? 2 and 5. Get a point. We're going to skip it for now. Okay, let's go to number 2. How does that plus 3 make me move? And Paige's group gets another point, up 2. So I literally am going to take my original guy. He used to be at the origin. I move right 3, up 2, and I think that's my first point. And again, I know it's over 1 up 1 because square root of 1 is 1. Over 4 up 2 because square root of 4 is 2. And if I had room, square root of 9 is 3. It would, bless you. Thank you. You're going to have a 0.5 for fixing me. And Paige, I was totally with her. It's the opposite of what we think. So a plus 3 would be left 3. Bless y'all. So I was supposed to move left 3. 1, 2, 3, up 2. Thank you. But it's still over 1 up 1, over 4 up 2. Now I can actually go over 9. 5, 6, 7, 8, 9, up 1, 2, 3. Again, and how am I picking these numbers? Because I know the square root of 9 is 3. If I had room, I'd go 16 and 4. And then 25 and 5. I'm using my perfect squares. So the gray one is correct. The pink one is when me and Paige run a different rant. But the good news is me and Paige would have never missed it because we're always going to check ourselves in the calculator. So we're going to be lazy like Justice. We're going to go to our calculator because I think I'm right and I think that's the right graph, but clearly I need to check myself. So y equals second square root x. I need it to be a plus 3 and a plus 5 plus 2. What have I done wrong? Yes, thank you. And Gilberto had it first. We'll give him the point. Make sure your plus 2 is outside of the house, or else you're going to mess it up too. Now, again, that looks like what I graphed, but I'm not really sure. I need specific points to plot on my table. So I'm on my graph. So I'm going to press second table. 13, 6. I can't quite reach that. I got to go lower. 6, 5 is the point it suggests. 6, 1, 2, 3, 4, 5. Hey, we already had that point. 1, 4. 1, 1, 2, 3, 4. Hey, we already had that point too. I wonder why. Oh, it says negative 2, 3. Oh, we had that one as well. And then negative 3, 2. Yay. How do you get from under the radical?
Yeah,
I don't understand. How do you get from under the radical? Oh, I literally scroll. Oh, I understand what you're saying. Like if I put the plus 2 there and that was wrong, you press delete and delete it. And then you want to make sure you scroll an extra time over. So the buttons down here, press the right button one more time. So like you're under the radical right now, because it kind of shows that I'm under the radical where it's lighting up at, and then press it over one more time. Well, then still just, even if it's not lighting up, press it over a couple more times. Like, that won't hurt. Are you using a black one right now? Oh, yeah, but just press it over one more time. It shouldn't hurt. Okay. Any other questions on number 2? We still got to come back and do domain and range. Okay, number 3 and 4. Why are 3 and 4 harder? I swear I have English. They do. And so 5 gets the point. I know the minus 5 makes me move right 5. I know the minus 6 makes me move down 6. What does the 2 make me do? It does change the width. Does it make me fat or skinny? It makes you skinny because what makes you fat? Fractions make you fat, so I already know on this one it's a fraction, so I'm going to be fat. Okay, and so when we say skinny and fat, and we're talking about an arm, we're literally meaning like skinny and fat. Like, is the arm going up or is the arm going down? Are we getting less lazy with our high five or even more lazy with our high five? Okay, so for us, I said right 5 down 6. So right 5 down 6. And then since it's skinny, instead of over 1 up 1, it should be, because of that 2 out front, it should be over 1 up 2. Instead of over 1, 2, 3, 4 up 2, it should be over 4 up. 2 times 2 is 4. So I'm assuming it's going to be, again, when I say skinny, it's getting like a less lazy high five. I'm assuming it's going to look something like this. But again, I totally understand being lazy. I'm going to check it with my calculator. Anyway, if you're not wanting to really understand this and you're going straight to your graph calculator, as long as your graph is right, I will never know. So 2 second square root, x minus 5, out from under the radical minus 6, press graph. Looks kind of like mine, but let's make sure. I go second table. I got some errors. Let's see. I can do 5, negative 6. 5, negative 6. Hey, I already did 5, negative 6. I can go 6, negative 4. 6, negative 4. Hey, I already did that too. I could go, the next pretty number I see is 9, negative 2. 7, 8, 9, negative 2. Hey, I already picked that one as well. So I'm never going to know if Justice is doing this in his head or if he's just straight up using his calculator. How many points do I tend to put on each graph? Yes. Who is Kitty West? I'm still recording. I hate group text messages. Don't group text me in the middle of a school day about some... I don't know who that is. I don't know why she was arrested. I don't care. Okay. Ah! Sister-in-laws. I hope she doesn't ever discover I have a YouTube channel. Okay, let's move on to the last one. Oh, yeah, I would like she'll pick the one video the one time I mention her, please.
Wait, what's your... Oh my God.
I will punch you. Okay, so number 4 is our hardest one yet. 1, because of the fraction making me fat. The minus 1 is going to make me move right 1. The minus 4 is going to make me move down 4. But I'm going to be super lazy like Justice. And I'm going to go ahead and graph it on my calculator first, before I even make my guess. Justice has forgotten how to put a fraction in his calculator. How can we help him? Say what now? How can we put this fraction in our calculator? Alpha what? That's what I do. I literally just do parentheses. If you don't put parentheses, you're going to get it completely wrong. So there's one option. There are 2 more options. One first period came up with that I didn't come up with. That's one option. So I could do this and keep going and get the graph right. What are my other options? Justice has forgotten. I'll give you a hint. I already said it's alpha. It's alpha something. And then my third suggestion is, can't you make it a decimal? If you made it a decimal, what would it be? Yes, so negative 0.5 or negative 0.5. It is alpha y equals, and you could say I want to do a decimal, so negative 1 divided by 2, 2. So any of these are going to work. They're all completely acceptable. But I am like Paige, and I don't have time for all this extra button pushing. And I like parentheses, so I would probably just do parentheses, negative 1/2. Okay, so it says second square root of x minus 1, scroll over 1, minus 4. So I have it looking like my paper. I press graph, and oh crap, this looks weird. Why does this look weird? Why is it going down? Is the fraction the reason it looks weird? It's that, yes, 2 gets the point. It's that negative. We never even addressed it. The negative made me flip. So instead of being a high five, so far I've been a high five. Now I've been a lazy high five, but I've been high five, high five, high five. Finally, we got this negative, and I'm a low five. It literally flipped our function. We used to be up like this, now we're down like this. A low five. So negatives turn you into low fives. Okay, so if I were guessing, I would have guessed, so I started at the origin, it said down 4, right 1. It flipped me down, so instead of over 1, up 1, I would have gone over 1, down 1, but darn you a half, it'd be over 1, down a half. I would have gone over 1, 2, 3, 4, down 2, but darn you a half, half of 2 is 1, so I would have done this. And then 5, 6, 7, 8, 9, half of 9 is 3, so I would have gone 1.5. But again, this is just me guessing. Angel already figured out the best way to make sure my points really are correct, which is, why don't I press second table? Everybody on Earth can press second table. It says one pretty point is 5, negative 5. I got that one. Another pretty point, 1, negative 4. And then I told you I like 3 pretty points, and oh no. But I'm not dumb. I can graph 2, negative 4.5. I just go between the 4 and the 5. Now, Cooper might not be good enough, and neither am I, to graph negative 4.866. But I can graph 4.5. It's halfway. In fact, if I kept going, I bet I could even graph 10, 5. Yeah, I could totally go over here to 10 and negative 5.5. That's possible. If only my grid kept going. So I've got my points. I connect my dots. And I'd say we call it a day. But we're not completely done. Are there any questions about the graphing? Come show me your calculator, baby doll. I'm not going to know what on earth you're talking about until then. What are we going to go back and do really fast before we call it a day for reals? Yeah, we got to go back and do domain and range. So if you want to go be making a prediction while I talk to her, that would be smart.
And then the light can't go.
You got to close your parentheses. It opens parentheses for the square root symbol, and you got to close it. Because your calculator is smart. So now, like, plus 6 on the outside. You just got to close the parentheses. No, that's a legit question. Okay, let's go do domain and range really fast. I'll remind you. No, I won't. We did domain and range with piecewise for so long. My gosh. Domain is X's or Y's. Yes, thank God. And range is Y's. So we're not looking at the pink one. We're only looking at the green one. We would drive along the x-axis, and we're trying to see when we can first reach out and touch that green graph. I can first touch that green graph at 5. I was driving along the x-axis. The first spot I could touch that green graph was at 5. So I'm putting 5 infinity. Why do I put the bracket? Why do I put the bracket? Why not just a parenthesis? Why do I put a bracket? Oh, Lord, help me. Why do we put the bracket? The bracket meant I could do this at 5. I could literally touch it at 5, hence I put the bracket. Okay, and then the range, we would drive from hell up to heaven. So I'm driving along. When can I reach out and touch that x-axis? Touch that green graph. When can I reach out and touch that green graph? The first time I can reach out and touch that green graph is at 0. So my range starts at 0. And then once I touch him, I'm able to touch him from there on out. I can keep on reaching out and touching him. So 0, infinity. I'll give a point per domain and range. What is the domain of number 2? Is that the first place you could reach up and touch him? -3, yes, thank you, ma'am. I can reach up and touch him starting at -3. Then on out, I can touch him. So we say -3, infinity. As for the range, I'm driving along that y-axis. Driving along. When can I first reach out from the y-axis and touch the graph? 2. So the person who said 2 earlier had it correct. They just were giving the range instead of the domain. So to infinity. And you can have your point. Are there any questions about these two domain and ranges? Let's do the last two. On 3 and 4, what is the domain on 3? Say what now? It is, I could reach out starting at 5, so it is 5 infinity. Bless you. And then the range, I could reach out and touch my graph starting where? I'm driving along the y-axis. When can I actually reach out and start touching it? When did that start happening? -6, and you can have another point, so -6 infinity. Are there any questions about number 3's domain and range? Number 4 is the hardest. Let's do the domain. It's not that bad. So domain, I'm reaching out along the x-axis. I'm trying to touch it. When can I first reach out and touch my graph? When can I reach out and touch that pink thing? When's the first time? At 1. So 1, infinity. And now for the range, I'm driving along that y-axis. Oh no. I can touch him down here. I can touch him, I can touch him, I can touch him, I can touch him. So, but can I touch him at -3? Can I reach out and touch that pink thing at -3? No. I can touch him at -4 though. So, what do we put for our range? It's different. Right, so we could touch him all the way in hell, all the way up until -4, and then after -4, we could not touch him anymore. Okay, you have 4 that I will check on Monday. It's these 4 right here. Which one is the hardest? 6 you want to say because of the fraction, but that's not true.
I think it'll be number 7.
7, because that negative sign is going to affect the domain and range. If Angel comes and shows me her paper and she doesn't have domain and range, I'm going to send her back. The good news is you've got 4 problems. The 4 graphs are on the back of the paper. If you were fast, you could probably knock them out now. How fast are you?